The journey of a photon of sunlight from the outer atmosphere to the forest floor is an epic tale of physics and biology. A story that begins with our star's nuclear fusion and ends with the subtle whisper of a plant's growth. Sunlight arrives at the top of the rainforest canopy as full-spectrum radiation, but the leafy ceiling, often over 150 feet high, acts as a dynamic, living filter. The uppermost layer, the emergent layer, is composed of towering giants like kapok and Brazil nut trees that bask in unfiltered, brutal sunlight. Their leaves are often small, waxy, and leathery adaptations to prevent water loss and photodamage from intense ultraviolet and visible light. This is where the first major interception happens. Approximately 70 to 80% of the total solar radiation is absorbed or reflected by this emergent and the primary canopy layer beneath it. The science here is profound. Leaves don't just block light, they manipulate it. Chlorophyll pigments primarily absorb the blue and red wavelengths of visible light for photosynthesis, reflecting and transmitting the green, which is why our eyes perceive the canopy as a vast green carpet. But the story deepens in the understory. The light that trickles down is radically transformed. It becomes a dim, greenish, and diffuse glow akin to the light in a colossal cathedral. This is because the canopy has filtered out most of the photosynthetically active radiation part. The photons that reach the lower shrubs, ferns, and seedlings are scarce and spectral shifted. This scarcity drives incredible evolutionary innovation. Understory plants have become masters of low-light efficiency. Their leaves are often large, dark green, and thin, maximizing surface area to capture every precious photon. Some, like certain philodendrons, even develop iridescent blue leaves that use nanostructures to bend light more effectively into their photosynthetic cells. Furthermore, the pattern of light on the forest floor is never static. It's a dazzling, ever-changing mosaic of sun-flecks brief, intense patches of direct light that break through when the wind moves the canopy. Research from the Smithsonian Tropical Research Institute shows that these sun flecks, which may constitute only about 10% of the daytime hours, can provide up to 80% of the daily carbon fixed by understory plants. The entire forest productivity hinges on this fleeting, dappled light. This complex filtering system doesn't just feed plants. It dictates the forest microclimate. The absorption of solar energy drives transpiration, where water drawn from roots is released as vapor from leaves, creating the rainforest's characteristic humidity and seeding clouds. This local hydrological cycle is entirely initiated by the canopy's interaction with sunlight. The temperature difference between the sun-baked canopy and the cool, dark floor can be as much as 10 degrees Celsius, creating stable, layered habitats for biodiversity. Every beam of light is thus a currency in an ecological economy, powering photosynthesis, driving weather, and creating niches for millions of species. From the ultraviolet reflections that guide pollinators to specific flowers to the infrared warmth that shelters reptiles, the physics of light filtration is the invisible architecture upon which the visible riot of life is built. To disrupt this finely tuned system is to pull a thread from a masterpiece tapestry. And as we'll see next, this disruption is happening at a pace and scale that will stun you, fueled by data that paints a far grimmer picture than common deforestation maps suggest. While the image of a lone tree falling is powerful, the true scope of the threat to canopy light systems is hidden in terabytes of satellite data and peer-reviewed studies that reveal a crisis of fragmentation and degradation. We often hear the statistic that a football field of rainforest is lost every second. But that simplified metric masks the more insidious damage, the perforation and thinning of canopies. According to a 2023 synthesis of data from Global Forest Watch, NASA's MODIS, and the University of Maryland, only about 40% of the world's tropical rainforests can now be classified as intact forest landscapes. Contiguous, undisturbed stretches large enough to maintain their original ecological functions, including the full, complex light regime. The rest is a patchwork of logged areas, secondary growth, plantations, and farmland. This fragmentation creates what scientists call edge effects. When a forest is cut, the new edge is exposed to harsh sunlight, wind, and dryness. A seminal study in the Amazon published in Science demonstrated that these edges can experience microclimatic changes penetrating up to 1 kilometer inward. Temperature rises, humidity plummets, and the delicate, filtered light environment is flooded with harsh, direct radiation. This abiotic stress kills shade-adapted plants and trees, leading to a process of biomass collapse. The data shows that these degraded edges can lose 25 to 50% of their biomass carbon within the first few years, not from further logging but from ecological collapse. The canopy breaks open, the light mosaic shatters, and the forest literally unravels from the inside out. Furthermore, commercial selective logging, often touted as sustainable, is a major but stealthy disruptor. Research using LiDAR, light detection and ranging technology, which can create 3D maps of the canopy structure, reveals that for every tree legally extracted, up to 30 more are severely damaged or destroyed due to the construction of roads, skid trails, and collateral damage. This logging death creates a perforated canopy that, while still looking green from above, has its light filtering capacity severely compromised. The data on canopy connectivity loss is even more alarming than that on pure area loss. A 2022 paper in Nature Climate Change used advanced algorithms to analyze canopy structural integrity. It found that between 2000 and 2021, the global tropical rainforest canopy lost over 17% of its structural connectivity, meaning the seamless, layered architecture that creates the specialized light zones has been severely degraded. This degradation directly impacts climate change. The Amazon, once a robust carbon sink, is now teetering on the brink of becoming a net carbon source, according to a decade-long study published in Nature. One primary driver is canopy damage. A broken canopy means a hotter, drier forest floor, leading to increased tree mortality and susceptibility to fires, which then create more canopy openings. It's a vicious, data-confirmed feedback loop. This isn't just about losing trees. It's about dismantling the planet's most sophisticated solar regulator and water pump. The loss of this canopy light management system has direct, quantifiable consequences for global weather patterns, carbon storage, and biodiversity extinction rates that are hundreds of times above background levels. And as we'll explore in the next section, the ripple effects of this broken canopy touch your life in ways you feel every single day. From the stability of your local weather to the medicines in your cabinet. The disruption of the rainforest light filtering canopy is not a remote ecological tragedy. It's a direct assault on global systems that underpin human civilization and health. Let's start with the climate, the most profound connection. The Amazon rainforest alone, through the process of transpiration powered by canopy-filtered sunlight, releases approximately 20 billion tons of water vapor into the atmosphere daily. This flying rivers phenomenon, documented by Brazilian researchers, influences rainfall patterns across South America and contributes to atmospheric circulation that affects weather as far away as the American Midwest and Europe. A degraded canopy with reduced leaf area means less transpiration. Data from climate models show that large-scale deforestation in the Amazon could reduce regional rainfall by up to 40%, turning parts of the agricultural heartland of Brazil and beyond into arid landscapes, directly threatening global food supply chains. On a planetary scale, the canopy is a critical thermostat. By absorbing vast amounts of solar energy for photosynthesis and transpiration, it helps cool the Earth's surface. When the canopy is replaced by pasture or soybean fields, the albedo, the reflectivity of the surface, changes. Darker forests absorb more heat than lighter-colored farmland, but the cooling effect of transpiration is lost. The net result, confirmed by the Intergovernmental Panel on Climate Change, IPCC, is significant local and regional warming. This loss of the forest cooling service undermines global efforts to mitigate climate change, making targets like those in the Paris Agreement exponentially harder to reach. Now, shift from the macro to the intimately personal, your health and medicine. The dim, competitive understory, sculpted by limited light, is a crucible of chemical innovation. Plants struggling for survival in the low-light understory have evolved to produce a breathtaking array of complex chemical compounds to deter herbivores, fight infections, and suppress competitors. This biochemical arsenal is the world's largest pharmacy. Over 25% of modern medicines are derived from rainforest plants, and scientists have studied less than 1% of all rainforest species for their potential medicinal compounds. The National Cancer Institute has identified over 3,000 plants with active compounds against cancer cells, 70% of which are found exclusively in rainforests. For example, the rosy periwinkle from Madagascar, a plant of the understory, gave us vincristine and vinblastine, drugs that turn childhood leukemia from a fatal diagnosis into a largely curable disease. The compound for the most effective anti-malarial drug, artemisinin, was derived from sweet wormwood, but the search for new antimalarial continues in rainforests as resistance grows. Every time a hectare of primary forest is degraded and its unique light environment altered, countless unknown plant species and their undiscovered chemical blueprints are driven to extinction before they are ever documented. We are burning the library of life before we've read the books. Furthermore, the broken canopy increases human exposure to zoonotic diseases. As wild habitats are fragmented and humans encroach, the buffer zone provided by intact forest ecosystems disappears. Diseases like Ebola, Zika, and various coronaviruses have been linked to ecosystem disturbance. The intricate light-controlled layers that separate species break down, increasing human-wildlife contact and the likelihood of pathogen spillover. Thus, the loss of filtered sunlight in a remote rainforest can indirectly set the stage for a global pandemic. The situation is dire, but the narrative doesn't end with loss. A powerful, evidence-based movement is growing, focused not just on stopping deforestation, but on actively restoring the complex light architecture of damaged forests. This goes far beyond simply planting trees. It's about canopy engineering, strategically rebuilding the layered light filtering system. Traditional reforestation often fails because it treats all trees equally, planting sun-loving pioneer species in open fields and expecting a rainforest to return. But a true rainforest canopy is a succession of light niches. Cutting-edge restoration ecology now uses a framework species approach. Scientists identify and plant a mix of 20 to 30 native tree species with different growth rates, crown architectures, and light tolerances. Fast-growing, light-demanding pioneers are planted to quickly provide shade and shelter, recreating a rudimentary canopy. Beneath their protection, slower-growing, shade-tolerant climax species, the future giants of the canopy, are planted. Data from long-term projects in Costa Rica's Guanacaste region and Brazil's Atlantic forest show that this method can accelerate natural succession by decades, bringing back key ecological functions, including a structured light environment, much faster. Technology is becoming a crucial ally. Drones are now used not just for mapping, but for sowing seeds. Companies like Biocarbon Engineering use drone swarms to fire specially designed seed pods into degraded land, capable of planting hundreds of thousands of trees per day in terrain inaccessible to humans. More fascinating is the use of LIDAR and hyperspectral imaging from satellites and aircraft to create high-resolution 3D maps of degraded forests. These maps allow conservationists to pinpoint exactly where the canopy is thinnest, where soil moisture is lowest, and where to focus restoration efforts for maximum impact on restoring the light and water cycles. There's also groundbreaking work in analog forestry, which designs agricultural systems that mimic the structure and function of natural forests, including their canopy layers. Farmers plant cash crops like coffee, cocoa, or spices under a restored canopy of native trees. This agroforestry system provides income while rebuilding habitat, cooling the local climate, and restoring the light diffusion services of a natural forest. Data from farms in India and Central America demonstrate that these systems can increase biodiversity by over 80% compared to monocultures while maintaining profitable yields. Perhaps the most futuristic frontier is assisted migration and climate-informed restoration. As climate zones shift, some rainforest areas may become too hot or dry for their current tree species. Scientists are now conducting trials to identify and plant species that are resilient to future climate projections, essentially future-proofing the canopy. This is a controversial but data-driven strategy to ensure these ecosystems don't just return, but persist in a changing world. Furthermore, economic case is being solidified. The Economics of Ecosystems and Biodiversity (TEEB) initiative quantifies the value of ecosystem services provided by intact forests, including climate regulation, water provision, and pollination. Their reports show that the long-term economic benefits of preserving and restoring forests outweigh the short-term gains from conversion by a factor of 3 to 1 or more. This data is crucial for persuading governments and businesses that a standing forest, with its intact canopy, is a more valuable asset than a cleared one. Understanding the crisis and the solutions is vital, but knowledge without action is meaningless. This is where you, the viewer, become an indispensable part of the solution. Your power as a digital citizen and consumer is far greater than you might think, and it starts with channeling the awareness you've gained from this deep dive into tangible daily actions. First, wield your financial vote with precision. Support companies and brands that are transparently and verifiably committed to deforestation-free supply chains. Look for certifications that go beyond mere marketing, like the Forest Stewardship Council, FSC for wood and paper, the Rainforest Alliance seal, particularly their 2020 certification program, or direct commitments like the Consumer Goods Forum's Forest Positive Coalition. Use apps like Globe or Donwood that can scan products and provide sustainability ratings. Reduce your consumption of products directly linked to deforestation. Beef, a primary driver in the Amazon, palm oil, Southeast Asia, soy, and tropical timber. When you do consume, choose recycled or alternative materials. Second, become a savvy supporter of conservation. Not all charities are equally effective. Move beyond just donating based on emotional appeals. Research organizations that use data-driven, on-the-ground strategies. Support groups that focus on securing land tenure for indigenous communities. Numerous studies, including from the World Resources Institute, show that forests managed by indigenous peoples have deforestation rates far lower than even protected government parks. Organizations like the Rainforest Trust, the Amazon Conservation Team, and the World Land Trust work directly on this model. Also, support science-based restoration groups like the Eden Reforestation Projects, which employs local communities to plant native trees, or One Tree Planted, which partners with expert on-the-ground organizations. Third, leverage your digital voice to create accountability. Follow and amplify the work of investigative environmental journalists and organizations like Global Witness or the Environmental Investigation Agency. Use social media to tag and question brands about their supply chain sustainability. Public pressure has forced countless corporations to change their policies. Participate in citizen science platforms like Zune versus Rainforest Connection Project, where you can help analyze audio recordings from the forest to detect illegal logging activity. Your screen time can become patrol time. Fourth, influence policy from wherever you are. Even if you don't live near a rainforest, your government's trade policies, foreign aid, and climate commitments matter. Write to your political representatives demanding support for international agreements that protect forests, such as enforcing regulations against importing deforestation-linked commodities. Advocate for your local pension funds or university endowments to divest from companies with poor environmental records. Political will is created by sustained public demand. Finally, and most fundamentally, change the narrative. Talk about what you've learned here. Share this video. Discuss the concept of canopy light and ecosystem services with friends and family. We protect what we understand and value. By shifting the conversation from vague saving trees to the precise, awe-inspiring science of the canopy as a planetary life support system, you help build a culture of informed stewardship. So, there you have it, the epic story of sunlight through the canopy, from a miracle of physics to a system in peril, and the burgeoning global effort to reclaim it. This isn't just about faraway jungles, it's about the stability of our climate, the future of medicine, and the legacy we leave. You are now armed with original, data-driven knowledge that most of the world doesn't have. But this information is a tool, not a trophy. It demands to be used. Start today. Pick one action from the final paragraph and do it this very week. Whether it's auditing your shopping cart, researching a single charity to support monthly, or sending one email to a representative, that specific act ripples outward. And to keep this momentum going, to dive deeper into how you can build a sustainable life and advocate effectively, your next step is crucial. Subscribe to this channel right now. Hit that like button to push this evidence-based content to more people, and ring the bell so you don't miss the next detailed blueprint for action. I'll be in the comments for the next hour to answer your questions and discuss your action plans. Let's build a community that doesn't just watch the world, but actively defends its light. The canopy's fate, and ours, is being written now. Be one of the authors.